code letter on a motor indicates its starting current, also known as inrush current, characteristics. This code letter is crucial for determining the appropriate size of a motor disconnect following the guidelines set by the National Electrical Code, or NEC. Different code letters correspond to varying levels of starting current relative to the motor's full load current. For example, a motor with code letter typically exhibits a normal starting current around 400% of its full load current. A motor with code letter B demonstrates a higher starting current, approximately 800% of its full load current. And a motor designated with code letter C has a very high starting current, around 1200% of its full load current. To accurately size a motor disconnect, firstly determine the motor's full load current, or FLA. This value is found in the motor's nameplate. Secondly, multiply the full load current by the code letter coefficient. This calculation provides an estimate of the motor's starting current. For instance, a motor with a full load current of 10 amps and a code letter B would have an estimated starting current of 10 amps times 8 equaling 80 amps. Thirdly, select a disconnect that is rated for the calculated starting current. The disconnect must be capable of handling the inrush current without tripping. Fourthly, verify the selection against the NEC requirements. The NEC mandates that the disconnect be sized in accordance with the overcurrent protection device that serves the motor. The disconnect's rating must not exceed that of the overcurrent protection device. In addition to the code letter, other factors may influence the disconnect sizing. These include the type of load the motor is driving, the motor's operating speed, and the temperature of the environment in which the motor is located. For motors that do not have a code letter marked, it is recommended to size the disconnect for a starting current of 600% of the full load current. The NEC also provides specific guidelines for sizing disconnects in situations involving multiple motors or motors with variable speed drives. The process of sizing a motor disconnect involves firstly determining the motor's full load current from the motor's nameplate. Secondly, using the motor's code letter to determine the inrush current. Thirdly, selecting a disconnect switch rated to handle that current without tripping. Fourthly, ensuring compliance with all applicable requirements of the NEC. These steps, combined with a comprehensive understanding of motor characteristics and the NEC guidelines, are essential for ensuring the safe and effective operation of motor-driven equipment. Let's further elaborate on the key factors and considerations when sizing motor disconnects, expanding on the initial points to offer a more comprehensive understanding. Firstly, the motor's full load current is a critical parameter. It represents the amount of current the motor draws when operating at its rated horsepower and voltage under normal load conditions. This value, typically expressed in amps, is found in the motor's nameplate and serves as the foundation for calculating the required disconnect size. Secondly, the motor code letter plays a vital role in determining the inrush current. As previously mentioned, the code letter indicates the motor's starting current characteristics, which can range from 400% to 1200% of the full load current, depending on the code. This inrush current is significantly higher than the full load current and must be considered when selecting a disconnect to prevent nuisance tripping during motor startup. Thirdly, selecting a disconnect switch with an appropriate rating is crucial for ensuring reliable operation and preventing equipment damage. The disconnect switch must be capable of withstanding the motor's inrush current without tripping, as well as carrying the full load current continuously without overheating. Factors such as the disconnect switch's interrupting capacity and horsepower rating should also be considered. Fourthly, compliance with the NEC is paramount for ensuring electrical safety and code compliance. The NEC provides specific guidelines for sizing motor disconnects, taking into account factors such as the motor's full load current, code letter, and type of overcurrent protection. Failure to comply with these requirements can result in electrical hazards, equipment damage, and potential code violations. In addition to these core considerations, several other factors can influence the sizing of motor disconnects. These include the type of motor, the application, and the operating environment. For example, motors used in hazardous locations may require specialized disconnect switches with explosion-proof enclosures. Similarly, motors operating in high ambient temperatures may require disconnect switches with higher temperature ratings. Furthermore, the presence of harmonics in the electrical system can also affect disconnect sizing. Harmonics are generated by nonlinear loads such as variable frequency drives and can increase the current flowing through the disconnect switch. In such cases, it may be necessary to oversize the disconnect switch to accommodate the harmonic currents. When sizing motor disconnects, it is also important to consider the potential for future motor upgrades or changes in load requirements. If there is a possibility that the motor may be replaced with a larger motor in the future, it may be prudent to select a disconnect switch with a higher rating to accommodate the potential increase in current. This can help avoid the need to replace the disconnect switch later on. Moreover, it is essential to ensure that the disconnect switch is properly installed and maintained. The disconnect switch should be installed in accordance with the manufacturer's instructions and all applicable electrical codes. Regular maintenance, such as cleaning and tightening connections, can help prevent premature failure and ensure reliable operation. In summary, sizing motor disconnects requires a thorough understanding of motor characteristics, the NEC guidelines, and various other factors. By carefully considering these aspects, it is possible to select a disconnect switch that provides adequate protection for the motor, ensures electrical safety, and complies with all applicable codes and standards. Remember to always consult with a qualified electrical professional when sizing motor disconnects to ensure that the installation is safe and compliant. Proper motor disconnect sizing is crucial for electrical safety and reliable operation. A motor disconnect is a switch used to isolate a motor from its power source, allowing for safe maintenance or repair. Selecting the right size disconnect involves several factors, including the motor's full load amps or FLA, the motor's code letter, and the requirements of the National Electrical Code or NEC. The motor's full load amps, or FLA, is the amount of current the motor draws when operating at its rated horsepower and voltage. This information is found on the motor's nameplate. The disconnect must be rated to handle at least 115% of the motor's FLA. For example, if a motor has an FLA of 20 amps, the disconnect must be rated for at least 23 amps. The motor's code letter indicates the motor's starting current or inrush current. This is the amount of current a motor draws when it first starts up, which is significantly higher than the FLA. The code letter is also found on the motor's nameplate, and it ranges from A to V. Each letter corresponds to a different range of inrush current as a multiple of the FLA. For example, a motor with a code letter B has an inrush current that is 3 to 3.99 times the FLA. A motor with a code letter H has an inrush current that is 6.3 to 7.9 times the FLA. The disconnect must be sized to handle this inrush current to prevent nuisance tripping. The NEC provides specific guidelines for sizing motor disconnects. These guidelines take into account the motor's FLA code letter and the type of overcurrent protection being used, such as fuses or circuit breakers. Generally, the disconnect must be rated for at least 115% of the motor's FLA and must be suitable for the motor's inrush current. For motors with high inrush currents, the NEC may require a larger disconnect or a time delay fuse to prevent tripping on startup. In addition to these factors, it is also important to consider the disconnect's voltage rating, horsepower rating, and interrupting capacity. The voltage rating must be equal to or greater than the motor's voltage. The horsepower rating must be equal to or greater than the motor's horsepower. The interrupting capacity is the maximum amount of current a disconnect can safely interrupt in the event of a fault. It must be sufficient to handle the available fault current at the installation location. It is also crucial to select a disconnect that is appropriate for the environment in which it will be installed. For example, in wet or corrosive environments, an M4 or 4X rated disconnect should be used. In hazardous locations, a disconnect specifically designed for those environments is required. Here is a step-by-step guide to sizing a motor disconnect. Firstly, identify the motor's full load amps, or FLA, from the motor nameplate. Secondly, locate the motor's code letter on the nameplate. Thirdly, determine the inrush current based on the code letter and the FLA. Fourthly, select a disconnect that is rated for at least 115% of the FLA and is suitable for the inrush current. Fifthly, verify that the disconnect's voltage rating, horsepower rating, and interrupting capacity are adequate. Sixthly, ensure that the disconnect is appropriate for the environment in which it will be installed. Seventhly, consult the NEC for specific requirements and guidelines. Eighthly, when in doubt, consult with a qualified electrical professional to ensure that the disconnect is properly sized and installed. Consider a motor with an FLA of 10 amps and a code letter of G. According to the NEC, a motor with a code letter G has an inrush current of 5.6 to 6.3 times the FLA. Therefore, the inrush current for this motor is between 56 amps and 63 amps. The disconnect must be rated for at least 11.5 amps, which is 115% of the FLA, and must be suitable for an inrush current of up to 63 amps. A standard 30 amp disconnect would likely be suitable for this application, but it is important to verify that it has a sufficient interrupting capacity. Always refer to the NEC for the most up-to-date requirements and consult with a qualified electrician for specific applications. Remember that proper disconnect sizing is essential for ensuring the safety and reliability of motor installations.